Okay. So what I'm going to talk about first is the frequency calibration for SDRs. And, if you don't have a GPS, if you do, this is kind of academic. You should just use your GPS. Sounds good. The problem is, and I'll try to relate this to satellites, is at UHF frequencies are higher, there's no WWV. So what do? So one way, and the details are in the paper, so I'm not going to read charts. That would be not too good. So I'm going to use a very inexpensive RTL SDR, and you'll see one back there hooked up. And I'm going to read the Atsc pilot tones. So as it turns out, every high-definition TV signal has a pilot tone. And its frequency used to be controlled by rubidium and cesium oscillators. Unfortunately, they changed the requirement, so half of them are controlled, at least the lower power ones, are controlled by GPS. But if you know where the frequency is, and it shows it exactly in the paper, you can go look at that frequency and then compare your frequency, what you think your receiver is receiving, compared to that. So essentially you have, assuming you have a high definition TV in your area, all kinds of WWV stations. So we do that. So the other thing you can do, and so if you just have, for instance, one of these in the area and you're not really sure of its frequency, you can have one ham go measure the frequency. As it turns out, it really doesn't change unless there's a problem with their software, which I'll talk about in a second. But they're all, as I said, rubidium controlled or cesium, so they're really not going to change. If somebody measures it and then you measure it remotely, you're going to be on the same frequency. So it works really good. And these are some of the other ways. You can have somebody else measure it, and then you can use their signal. You could buy an SDR that has a GPS built in. Assuming you're not indoors like back there, it doesn't do you much good. So anyway. Okay, talk about the tone. That's actually the frequency. That's channel 14, and yes, all those digits are actually what they spec, even though the requirement for the FCC was plus or minus a half a hertz, so don't get your hopes up. Right? I have measured with a very accurate source the stations in the Boston area, and I'd say out of the 14 stations that I can receive, I'd say 10 of them are within a half a hertz. The other ones, not so much. In fact, here in your area, I turned it on last night, and you can see back there, you have one station that's off a kilohertz. It still works. All the receivers have automatic frequency control, so not really an issue. So, getting right down to it, I'm not going to go over the GNU radio, so both of my talks are done in GNU radio. If you're really interested, you can go up to the GitHub site. That's mine, and hopefully we'll port it over to Michelle's as soon as I figure out how to do that correctly. But you can go get it on that location, and that's a short snap of what it is. Here's a block diagram for those who are interested. We have SDR receiver. In my case, I'm using a dongle. Offset the carrier to remove the DC component. I have a offset tuning that I can do, and waterfall display and zoom frequency. And one of the main things with an RTL dongle is setting the PPM factor. So they tell you, yeah, you can set it, but you don't know how to set it. You don't know how far off you are. And this program will let you determine a pretty good number to set. So you don't know if it's 14, it's 16. The other way to do it, by the way, you could use something like Sdr Console by Simon Brown. Great program. Would advise you to get it. In that program, you can tune to one frequency and see it exactly too. That works very well also. Okay. So here's what I did. Created a waterfall, and then you can set a single frequency, or you can program your favorite 6 stations in the area, and it'll jump between them, or you can listen to all the frequencies. And what it'll do is you'll see it on a waterfall how accurate you are. So this is the result. You can see on an RTL dongle, it's kind of not exactly aligned, but they're pretty good, right? So you look at the scale here, you're within like 100 hertz. So that's pretty good. And here it shows you can, this is the tab where you can select which mode you're in. And I'll show you which frequency you're on and, display the channel. So here you can input your frequencies to know which channel you're going to jump to. Whoops, wrong way. And there what do you know? So you can type in all these things. And you can zoom up on your station of interest. Now, instead of using an RTL dongle, right after this, I plugged in an Atsc 210. You notice the line looks pretty straight. So, and this is without GPS on, and looks pretty good. So this is, I'll call it uncalibrated. There's a way to calibrate the Atsc. I didn't bother doing that. So it would actually look straighter if you calibrated it. But you notice this one station, yes, that station is off frequency. That does happen. As it turns out, that's a low power station, and so they probably are using a GPS and they didn't quite set it up quite right, but it really doesn't matter. It still works pretty good. But you can see it is pretty accurate. So with this program, a way for you to get at the data. And there's one station I saw in our area. It looked like a square wave. In fact, it looked just like this. It would jump off frequency. So as it turns out, one of the hams on our ascent call knew the guy who actually is another ham who was responsible for these guys technically. So I called him up, and he says, "Oh, their GPS is broken again." So I guess it's happened more than once. So I sent him the file so he could actually see what was going on, because he actually lives out of state. So anyway, if you're interested, demo will be in the back. And I'm going to combine the questions because we'll do the next talk right away.